When we look up at the night sky, it's easy to feel small,
Yeah.
like completely insignificant.
Right.
And, well, it's true in a lot of ways.
Hmm.
Today, we're going to try to understand something that's so massive, it makes entire galaxies look like grains of sand.
It's a great way to put it.
It's called the cosmic web. And to get a handle on it,
Yeah.
we're diving into excerpts from Wikipedia articles on galaxy filaments and the observable universe, a YouTube video transcript about modeling this web, and a really fascinating piece from astronomy.com,
It really is fascinating stuff.
breaking down what this mind-boggling structure is actually made of.
So we're talking about the largest known structure in the universe.
Okay.
Like a web of galaxies just strung out across unimaginable distances, held together by gravity and dark matter.
It's like those pictures you see of neurons in the brain.
I see that, yeah.
Except instead of microscopic cells, we're talking about galaxies.
Right. And to really get a sense of the scale, we need to start with what we know. We're all familiar with galaxies, right?
Sure.
Our Milky Way, for example.
Huge collections of stars, gas and dust.
Exactly.
Yeah.
Now imagine those galaxies themselves clustered into these enormous walls and strung out along these invisible filaments,
Invisible filaments.
stretching for billions of light years.
Okay, hold on. Billions of light years.
That's the cosmic web.
That's insane. How can something that big even exist?
Well, that's the thing about space.
Yeah.
It's mind-bogglingly big.
True.
And these filaments are just one piece of it.
So if we're picturing like a web, right?
Mm-hmm.
What are these filaments, like the threads?
Exactly. Imagine them as like cosmic superhighways connecting these massive clusters of galaxies.
So not just galaxies themselves, but clusters of galaxies.
Exactly. These filaments are made up of superclusters, which are already huge collections of multiple galaxy clusters all linked together.
Okay, so we're talking about structures that are basically beyond comprehension in terms of size.
Pretty much.
Yeah.
And to put it into perspective, one of the most famous filaments is called the Hercules Corona Borealis Great Wall.
Catchy.
Right. And it's estimated to be about 10 billion light years across.
10 billion. Our entire Milky Way galaxy is like 100,000 light years across.
Yeah, it puts things in perspective, doesn't it?
It does. How do scientists even wrap their heads around something that massive?
It took a long time and better technology.
Yeah.
It wasn't until we could really accurately measure redshift.
Which is how we figure out distances in space, right?
Exactly.
Yeah.
That we even realized these filaments existed. They're so vast and spread out. It's like trying to see the shape of a forest when you're standing right next to a single tree.
I get it. And to map them out, scientists use these things called gamma ray bursts, which are like...
Incredibly powerful explosions
How
when massive stars die.
So they're using the light from dying stars to map out the universe's largest structures.
And it works because these gamma ray bursts are so bright, they act like beacons shining across the universe.
That's wild. So we've got these filaments, these threads of the cosmic web. But what are they actually made of?
Well, mostly it's something we can't even see.
Oh, come on. Of course it is.
Dark matter.
Right.
Roughly 83% of the cosmic web's mass is dark matter.
Okay, so we're already dealing with something we can't even see.
Pretty much. We can't directly observe dark matter, but we know it's there because of its gravitational effects on the things we can see, like galaxies and light itself.
So it's like the invisible glue holding this whole web together.
Exactly. Think of it as the scaffolding, the framework upon which everything else is built.
Okay, so dark matter is the backbone of the cosmic web. What about the other 17%?
Good question.
Is that more familiar stuff?
Some, but not in the way you might think.
Okay, I'm intrigued.
Most of the rest is normal matter, but it's not stars and planets. It's mostly incredibly hot gas.
Hot gas.
Yeah, intergalactic gas that's trapped within galaxy clusters. And then there's something called the WM, which stands for Warm Hot Intergalactic Medium.
The WHM.
I like it. It's found within the filaments themselves.
So this WIM, it's like the cosmic plumbing system carrying all this hot gas through the universe.
I like that analogy. And the galaxies are like beads strung along these filaments, constantly interacting with this hot gas around them.
So it's not just a static picture. We're talking about a dynamic, interconnected universe where everything is moving and changing.
Exactly. It's not just stuff randomly scattered around.
And to try and understand how something this complex came to be, scientists have turned to computer simulations.
Right, like that YouTube video you mentioned earlier.
Yeah, where they were basically playing cosmic architects.
Exactly. They were simulating the universe to see if they could recreate this web and the way galaxies are distributed and get the simplest model they tested.
Okay.
Where they basically just connected galaxies based on proximity. Like if they were close together, they were more likely to be connected,
Right.
Turned out to be surprisingly accurate.
So just that simple rule of proximity was enough to create something resembling the cosmic web.
It seems that way, which is amazing when you think about it. The universe has this tendency towards order, this emerging complexity that arises from relatively simple rules.
It's like the universe read the cosmic construction manual and decided to skip ahead to the advanced section.
Yeah, kind of like that.
Amazing. So we've got these filaments stretching across billions of light years made of dark matter and hot gas, and they're all connected in this intricate web. It's mind-boggling to think about.
It really is, and we're just getting started.
So we've got these filaments, these massive threads of dark matter and hot gas stretching across billions of light years.
It's pretty mind-blowing when you think about
It
it.
really is, and it's all connected in this intricate web.
And it's constantly evolving.
It's evolving.
Yeah, it's not static.
Yeah. So what does that even mean? Like on a cosmic scale, are we talking about changes we could observe if we had a really powerful telescope in a whole lot of time?
Not quite. We're talking about changes that happen over billions of years.
Billions of years.
Yeah, it's hard to even fathom.
So this cosmic web, it's like a slow motion dance.
Either way, yeah.
So what's driving those changes? Is it just the expansion of the universe, or is there more to it?
Well, the expansion plays a role, but there's more going on within the web itself.
Yeah.
Remember all that hot gas we talked about? The WM?
The cosmic plumbing.
Exactly. All that gas is constantly moving. It's being pulled by gravity, flowing into galaxies, fueling star formation, getting blasted back out by supernova explosions.
So it's like a giant, chaotic cosmic ballet.
Yeah, you could say that. And all of that movement, all of that interaction, it shapes and reshapes the cosmic web over time. Filaments can merge. They can split apart. And who knows, maybe even entirely new filaments can form as the universe continues to expand.
So it's not like the filaments are just frozen in place. They're more like cosmic rivers with galaxies caught in the current.
That's a great analogy.
Hmm.
And just like rivers, those cosmic flows can change over time,
Mm-hmm.
which means that even a structure as enormous as the Hercules Corona Borealis Great Wall might not be permanent.
So even something that big can change over time. It's both humbling and awe-inspiring at the same time.
Definitely. And it makes you wonder what the future holds for the cosmic web.
What happens when these filaments merge or split apart? What happens to the galaxies caught in between?
Those are questions that cosmologists are still trying to answer.
It's like we're trying to understand the life cycle of a creature that lives for billions of years.
Exactly, and we're just getting started.
So we've got this cosmic web, this massive structure of filaments and galaxies, and it's constantly evolving. What does that evolution actually look like? Are we talking changes we could observe in a human lifetime, or is this a watch paint dry kind of situation only on a cosmic scale?
It's definitely a much longer time scale than a human lifetime. Think billions of years. But that doesn't mean it's not happening. Remember that hot gas we talked about? The stuff flowing through those filament pipelines? The WIMM?
Yeah, like the cosmic plumbing?
Exactly. It's constantly being pulled by gravity, flowing into galaxies, fueling star formation, getting blasted back out by supernova explosions.
It's like a giant, chaotic cosmic dance.
Exactly.
Yeah.
And all of that movement, all of that interaction, it shapes and reshapes the cosmic web over eons. Filaments can merge, they can split apart. And who knows, maybe even entirely new filaments can form as the universe continues to expand.
So it's not like the filaments are just frozen in place. They're more like cosmic rivers with galaxies caught in the current.
That's a great way to put it. And just like rivers here on Earth, those cosmic flows can change over time, which means that even a structure as enormous as the Hercules Corona Borealis Great Wall might not be permanent.
Wow, it really puts things in perspective, doesn't it? We're so focused on our own little corner of the cosmos, our own fleeting moment in time. But out there, the universe is playing out this grand billion-year-long game of cosmic Jenga.
And the amazing thing is we get to be a part of it, to witness it, to try and understand it. We've talked about filaments, dark matter, simulation. It's a lot to take in.
It really is. But even if our answers only lead to more questions, that pursuit of knowledge, that sense of awe and wonder is what makes exploring the cosmic web so incredibly rewarding.
I completely agree. It's like we're standing on the edge of an infinite ocean and we've only dipped our toes in the water. Who knows what incredible secrets we'll uncover as we venture further out.
That's something to ponder, isn't it? The vastness of the cosmic web, the mysteries that remain. Until next time, keep looking up and never stop questioning.